That's pretty basic.
Yeah, this is. I'm also recording it for Rebecca, so I'm just going to talk through it real quick.
Rebecca is pretty basic.
All right, Rebecca, Zach said this is pretty basic. So law of conservation of energy. Energy can't be created or destroyed. It's only transferred from one form to another. So total initial energy in a system is going to be equal to the total final energy. So typically when we're dealing with just like mechanical energy, so you've got, we're working with kinetic and gravitational potential. So like if I have my pen holding it here, right, it's not moving, so it has no kinetic, but it's got all gravitational potential. And then as it falls, right, our gravitational potential is decreasing, our kinetic is increasing, so that amount of energy is staying the same.
The things always fall at the rate of gravity.
Now you've got air resistance and other things factored in there too. But we are just going very broad and basic with this level of physics. So to find out different the types of energy or the amount of energy at different parts, right? You've got your kinetic initial, gravitational potential initial. Add those together. That's equal to the kinetic and gravitational potential added together for final. So let's look at example 1. So diver slips and falls off of the diving board. If the diving board is 10 meters high, what's the diver's speed right before he hits the water? All right. So no, that's acceleration due to gravity.
What?
It's not 9.8 meters per second. All right, so remember that kinetic is 1/2 mv squared. All right, so that's the initial, and then okay, so that's just kind of our basic thing. But let's think about what's happening here. So he's standing on the diving board at the beginning, right? So does he have any kinetic energy at that point? No. Oh, sorry. All right, so since he doesn't have any kinetic energy, that is going to be equal to 0, so we don't need it. Right, he has no initial kinetic energy. And at the end, is he going to have any gravitational potential? Because we're talking about his speed right before he hits the water and it changes. All right, so that means that's going to be 0. So really, the gravitational potential energy at the beginning is going to be equal to the kinetic energy at the end. So since we have mass on both sides, we don't necessarily need the mass, right?
What is MGH equal?
Mass times 9.8 times height. That's gravitational potential energy. So we can cancel out the mass on both sides as well, right? Because we can just divide out that m, essentially. Does that make sense? Because the mass of the diver is not going to change from when he falls to before he falls to while he's falling. So G is always 9.8. Our height is 10 meters. Then we have 1/2 and final velocity squared. And that's what we're trying to solve for. So then we get 98 equals 1/2 VF squared. Multiply both sides by 2 to cancel out the 1/2. So 98 times 2 is going to give us 196. Take the square root of both sides. So V will equal, I believe it's 14 meters per second. All right, questions on how we did that? Does that seem fairly straightforward? Can I get a grunt of acknowledgement from somebody?
That's the one you comprehend.
I'm sorry.
I knew it.
It's not really cucumber, but.
Times 65 times 9.8. Right, so that's going to give us the total energy of the system. So that will be 46,501 joules. All right, so then for part B, we need to find how fast he's moving at half the height of the hill. Right, so half of our height would be what?
32.5.
Mm-hmm.
Yes, wow.
So that means the total energy is going to be equal to the gravitational potential at that half height plus the kinetic there. Is that a dog?
My son took a chihuahua and just beat his rib cage. And it had asthma.
That's really specific.
Y'all think I'm a murderer.
You talk about it all the time. I'd say history class is a little suspicious.
It's up and crazy.
It's funny though, it freaks me something out. It is pretty funny.
He keeps her distance from me when I'm in the hallway because he thinks I'm just gonna grab her and kill her.
My husband's like, don't say joke. Oh, tiny words. With these. I think so. Sure.
Right. All right. So we've got mass, gravity. That should be 9.8, not 9.3.
Why does it auto plug in numbers for me?
I don't know.
I'll be like 46,501 equals, and then it'll plug in 46,501
I don't
on
know.
the other side.
All right. So then,
It's not. It's some hard math. Yeah. Wow. Oh, we do that plus the.
we have that.
Oh, some buttons.
Right. Then we will subtract the 23,250.5 from the 46,501. Which is 23,250.5.
I know that's what I haven't asked.
Then divide it by the 36.5 and then take the square root. So we've got v squared,
Bless you.
or well, so 637 equals v squared. Take the square root of that. And get our velocity is
I know 637 equals 637.
25.2 meters per second.